In this video, we'll be developing the distance formula. So our question is to find the distance from the point x sub 1, y sub 1 to the point x sub 2, y sub 2. Now I just did a generic plot on our two-dimensional Cartesian plane. So I let this point up here be x sub 1, y sub 1. And this point be x sub 2, y sub 2. And so notice that I indicated my x-coordinate down here on the x-axis, x1, and my x-coordinate for this point down here on the x-axis, x sub 2. And then my y-coordinate for this point is over here on the y-axis, so that's y sub 1. And my y-coordinate for this point is over here on the y-axis, that's y sub 2. Now if we wanted to find this distance, since it's a rectangular plane, I know that I will have a right angle if I draw this line segment as my hypotenuse and then go straight down parallel to the y-axis for my vertical side and then straight over for my horizontal side parallel to the x-axis. So I know that this will be a right angle, which means that I can use my Pythagorean theorem. We can call this side A and this side B if you want, and this would be normally C for our Pythagorean theorem, and we know that that's A squared plus B squared is equal to C squared. So I need this distance of my vertical side, and then I need to square that. Well, if you want to find the amount of space between 2 points on a line, you just subtract those two numbers. And then we're going to square it. So I'm going to take y sub 2, subtract y sub 1, and then square that, and that'll be my a squared. Now if you wanted to take y sub 1 minus y sub 2, that would be fine. Even if you came up with the negative of the number that I would get here, when you square that, that would go away. So the order that you subtract those doesn't matter. Now let's do our B. That's this horizontal side here. Again, to find that length of that line segment, I just need to subtract these two numbers. So my plus sign, I'm going to bring that down. And then if I subtract x2, subtract x1, quantity squared, that'll give me my d, my distance squared. So to get d, I just need to square root both sides, and I can see then that d is equal to the square root of big old long square root. So remember that when you try to remember your distance formula. It's the big old long square root. Okay. And I normally put my x's first and then my y's. Again, it doesn't matter because addition is commutative between these two terms. So I'm going to write x2 minus x1 quantity squared plus y2 minus y1 quantity squared. So this is your distance formula. know it, memorize it, remember it, and do what you can to always, always, always have it on hand in your mental Rolodex. Now let's do one problem where we're going to kind of use this formula. So the problem that I want to do is use the distance formula to write an expression that gives the distance between the point 4, -2 and the point xy. Alright, so we know that it's going to be a big old long square root. And usually you put your variables first in an expression. So my expression will be open parentheses, x subtract 4. Let's go ahead and indicate this as my x1 and my y1 and my x2 and my y2. And that way it might help you with your formula. So I need to grab my x2, which is x, subtract my x1, which is 4, and then quantity squared, plus open parentheses, my y2, which is y, subtract my y1, which is -2, quantity squared. Alright, now after you've replaced each of these variables with a number, then you just simplify. The only thing we can simplify here is these two negatives. We can change to a positive. So my answer on this would be the square root of x minus 4 quantity squared plus y plus 2 quantity squared. And you wouldn't multiply that out unless you had to go further and do something else with it, and it would be beneficial. But this is fine to leave it like this.